Lorentz force F equals to Q ER plus V cross BR equals to F electric plus F magnetic. Only a moving charge feels the magnetic force. The magnetic force is 0 if the charge is not moving. This unit of magnetic field B is Tesla. In the presence of external magnetic field B, the force on their carrier is F equals to NAL Q VD cross B. In the case of motion of charge in magnetic field, the magnetic force is perpendicular to the velocity of particle. So, no work is done and no change in magnitude of velocity is produced, though the direction of movement may be changed. The radius of circle described by the charged particle of mass m and charge q moving with velocity v and magnetic field B is in the direction perpendicular to velocity is given as r equals to mv upon qb and omega equals to 2 pi mu equals to qb by m. Case in which electric and magnetic field are perpendicular to each other and also perpendicular to velocity of particle, the force is given as F equals to Q E minus Vb. Cyclotron uses the fact that the frequency of revolution of charged particle in a magnetic field is independent of its energy. Thus, frequency of particle mu c equals to Qb upon 2 pi m. The accelerated particle leaves the system via an exit slit with the velocity v equals to Qb r by m. The sign of electric field changes alternatively so that the particle is always accelerated by the electric field. Biot-Savart's law states that modulus of dB equals to mu naught upon 4 pi I dl sin theta upon r square and even mu naught epsilon naught equals to 1 by c square. Magnetic field on the axis of a circular current loop dB equals to mu naught upon 4 pi I dl upon x square plus r square. Ampere's law states that this integral is equals to mu naught times the total current passing through the surface, that is, surface integral B dot dl equals to mu naught I. The magnetic field due to solenoid is given as B equals to mu naught Ni. The magnetic field around the toroid is 0. The magnitude of force on the segment L of B due to A is given by FBA equals to IBLBA equals to mu naught IA IBL upon 2 pi d. In two parallel current carrying conductors, the current flowing is in the same direction, attract each other, and if in opposite direction, repel each other. The rectangular loop carrying the steady current I placed in a uniform magnetic field experiences a torque as tau equals to IAB. If the plane of the loop is not along the magnetic field but makes an angle theta with it, torque can be given as tau equals to IAB sin theta.